take a look at the first example. So the ladder is leaning against the side of a house, 12 meters above the ground. If the base of the ladder is 5 meters away from the house, how tall is the ladder? Well, we don't have a diagram, so sometimes you need to draw one. Kind of draw what's happening. So please just be mindful of my drawing. Okay. Here's our house. Okay. There's the house. We have a ladder leaning against the house, and the house and the ladder are sitting on the ground. Kind of just draw some rough diagram of the situation. We know the house is 12 meters above the ground, so we know the house is 12. And we know the base of the ladder is 5 meters away from the base of the house. We want to figure out, well, how tall or how long is the ladder? Well, what kind of shape did we just form? A right triangle. What can we do to find x or find the length of our ladder? What are we going to use? Yeah, how are we using it? Why are we using a Pythagorean theorem and not trig? Because why? We have two sides, so we can use the Pythagorean theorem. Which one has to be RC? The hypotenuse is always RC, then it doesn't matter, make one A, make one C. Plug it in. And solve for x. When we solve, what's 5 squared plus 12 squared? 169. And then what do we have to do to both sides? When we square root, x is equal to 13. So that ladder is 13 feet. Thank you. Questions over that? Well, the example involved using the Pythagorean theorem to solve a problem. We can also use those trig ratios to help solve problems as well. Okay, first, we need to discuss some important vocabulary. So the first vocab word is angle of elevation. That is the angle between the line of sight and the horizontal when you're looking upwards. So take a look at this diagram here. This person's looking up at the top of the tree. The diagonal line is acting as their line of sight. There's this imaginary horizontal line making an angle with that line of sight. If we go from the horizontal to the line of sight, I'm going upwards, right? That means it's an angle of elevation. The angle is opening upwards from the horizontal line. Angle of depression is the angle between the line of sight and the horizontal when looking downwards. So if we look at this diagram, the second diagram, we have that owl looking down at that poor squirrel. Okay? It's looking downwards. The diagonal is going down. With that imaginary horizontal making the angle with the line of sight, if I go from horizontal to the slanted line, my arrow is going downwards. Therefore, it's an angle of depression. The angle of elevation is always congruent to the angle of depression because they're alternate interior angles. Well, think about, if we look here at this diagram with the owl looking down at the squirrel. Well, the squirrel is sharing that line of sight and looking up at the owl. So whenever you have a line of sight, there's always that imaginary line horizontal. Right? You notice these horizontal lines are parallel to each other. So this angle, the angle of depression, and this angle, the angle of elevation, are going to be the same. Same thing in this diagram. The person's looking up at the top of the tree. Let's say the tree's looking down at the person. It's not, but let's just say it is. Okay? This angle of elevation is the same as that angle of depression. They're the same. Those horizontals are parallel to each other. The line of sight is acting as a transversal. And then same thing in this hot air balloon. The person's looking up at the hot air balloon, but person. Here's an angle of elevation. Here's an angle of depression. Those are the same. Again, those horizontals are parallel to each other. The line of sight acting as a transversal. So this angle right here, the angle of depression is 38. The angle of elevation is going to be 38. If we take a look at example 2, from the top of a fire tower, a forest ranger sees his partner on the ground at an angle of depression of 40 degrees. If the tower is 45 feet in height, how far is the partner from the base of the tower to the nearest tenth of a foot? Well, what shape? What do you notice you have here? A right triangle. What are we going to use to find that missing side in the right triangle? Trig. Why can't we use Pythagorean theorem? We only have one side. What's the problem, though? Where's our angle? It's on the outside, right? We were given an angle of depression. But what do we know about the angle of depression and the angle of elevation? They're the same, right? So this angle is an angle of depression because it's going downwards. This angle right here, that's my angle of elevation because it's going upwards. We're sharing this diagonal, this line of sight. So if this angle on the top is 40 degrees, we just slide it on down here. That angle is also going to be 40 degrees. The angle of depression and the angle of elevation are the same. Now that angle is on the inside, we can use SOHCAHTOA. We can use trig. Write down SOHCAHTOA. Start with your angle and label. If we go across, that's our opposite. Go to our 90 across. That's our hypotenuse. Side left over is adjacent. Based off what we labeled, which two sides have info? And adjacent. So which one are we going to use? Tangent. So we're going to say tangent of 40, tangent of our angle, is equal to the opposite, which is 45, over the adjacent, which is x. X is down low, so what are we going to do? So they switch. So this becomes x equals 45 over the tangent of 40, and that's what you're plugging into your calculator. I'm going to use decimals. So I'm going to do 45 divided by tangent of 40. One around the nearest tenth of a foot. How many decimal places is a tenth of a foot? 1. So this would be 53.6. It's about 53.6 feet away from the base.
Can it be 54?
Nearest tenth of a foot is 1 decimal place. So it'd be 53.6. If it's a nearest whole foot, then yes, it'd be 54. If we take a look at example 3, it says a ladder leans against a brick wall. The foot of the ladder is 6 feet from the wall. The ladder reaches a height of 15 feet on the wall. Find them to the nearest degree. The angle the ladder makes with the wall. So what are we trying to find here? A side or an angle? An angle. What do we have to use when we find an angle? SOHCAHTOA. Pythagorean theorem. Yes, we were given two sides. But we never use Pythagorean theorem to find angles. We only use Pythagorean theorem to find sides. So we have to use SOHCAHTOA when you're trying to find a missing angle. Well, we're going to label from the angle we're missing. Go across, that's the opposite. Go to our 90, go across, that's our hypotenuse. The man seems very angry climbing that ladder. Side left over is the adjacent. Based off what we labeled, which two sides have info? Opposite and adjacent, so we are going to use what? Tangent. So we say tangent of our angle, tangent of x, equals opposite over adjacent. the angle's missing, it's not a curse. What are we going to use? The inverse. So we're just going to use inverse of tangent. Type in the fraction. Plug it into your calculator or Desmos. I forget the fraction already. 6 over 15. 6 divided by 15. Oh gosh, I need to do this. Some programming stuff they need to work out. 6 divided by 15. It said round to the nearest degree. So round to the nearest degree is about what? 22. So that angle is roughly 22 degrees. Questions over that? Not bad. Pretty much what you've been doing. Nice little picture that goes along with it. A little bit of angle of elevation and depression. If we take a look at the next two, those are a little more challenging. So Livia's in a lighthouse on a cliff. She observes 2 sailboats due east of the lighthouse. The angles of depression to the 2 boats are 33 degrees and 57 degrees. Find the distance between the 2 sailboats to the nearest foot. So I notice in my diagram I have 2 triangles. I have this purple one and this green one. I want to find the distance. I want to find this orange distance from A to B. What part in each triangle do we need to find? What do you think we need to find first? What part in each of those triangles? Which side? We only need to find one in each. Specific one. The bottom one. Good. We need to find the bottom of each triangle. We can find the bottom of the purple and the bottom of the green, and then do what with the 2 distances? Subtract them. And that will tell us what that orange part is. Well, if I look at my purple triangle, the problem is the angle is not inside the triangle. And we were given 2 angles of depression, so you have to figure out which one belongs to which triangle. Well, if I notice how this 57 is touching the purple triangle, that's the purple triangle's angle of depression, which means it's also its angle of elevation. What do we know about our angle of depression and our angle of elevation? They are what? The same. So if this angle right here is 57, that means this angle right here is also going to be 57. If it's helpful too, you can draw the triangles outside of the diagram so it's not so messy. What is the length of this up and down side of the triangle? From the ocean to the cliff, it's 110, and then from the cliff to the top of the lighthouse, it's 85. So what's that total height right there? 195. So we know that's 195. I'll label it in the diagram as well. That's all we know when we're trying to find the bottom. So let's label. If we start at our angle and go across, opposite, 90 across, hypotenuse, side left over adjacent. If we look at SOHCAHTOA or your green formula sheet, you're allowed to use those. Just skip the letters. Which 2 sides have info? Opposite and adjacent. So which one are we going to use? Tangent. You use tangent a lot in these problems. In these more real world type problems. Sine will make its way in there. Cosine will make its way in there. Tangent is used a ton. Right. So we're going to say tangent of our angle is equal to the opposite over the adjacent, 195 over x. Is x up high or down low? Down low, so we are going to do what? So it becomes x equals 195 over the tangent of 57. Plug that into Desmos. 195 divided by the tangent of 57. And it's about to the nearest foot. 120 what? Oh, 127. One's just around the nearest foot, so we'll just round the nearest foot. 127. So that's the length of the purple part. Should have written all that in purple. But the length of the purple triangle, 127. We now need to find the length of the green triangle. And again, if it's helpful, redraw the triangle outside of the picture. We have this big green triangle. The green triangle's angle of depression is 33. That's the one it's touching. Which means its angle of elevation is also going to be what? 33. So this angle right here is 33. This angle right there is going to be 33. Which means in my outside diagram it's 33. They share the same height. So this is also going to be 195. And we're still trying to find the bottom. So let's label our sides. If I go across, that's our opposite. So our 90 go across, that's our hypotenuse. Side left over is adjacent. Which two sides have info? Opposite adjacent. So which one are we going to use again? Tangent. And when we set up our ratio, tangent of 33 equals opposite over the adjacent. What do you notice about the second one we set up and the first one we set up? What do you notice about? X is in the same spot. What about the numerator? It's the same. What about the ratio used? It's the same. Everything's the same except for what? The angle, right? The first one was tangent of 57. The second one was tangent of 33, but everything else stays the same. There's a shortcut there for you. When you have these double triangle problems, however you set up the first one, as long as you set it up correctly, the second one's also going to be set up that same way. You just have to swap out the angle. Right? Now, if you set up the first one incorrectly, then you're going to set up the second one incorrectly. So double check your work. But, shortcut, the first one's just going to be like the second one. They're going to be the same, except you just swap out the angle. Okay? X is down low. So again, we switch a row. And plug it in your calculator. Again, even this is the same. We divided by 195 by the tangent of 57. Same thing, but we just swapped out the angle. Everything's going to be the same when you have those double triangle problems. So type it into Desmos or your calculator. And it's about 300. Now that we know the lengths of the two triangles, what did we say we had to do to them to find the distance in between the two boats? Track stuff, right? So we have to do 300 minus, what was the second distance? 127. So we have to do 300 minus 127. And what do we get? 173. So 173. There we go. 174. Okay. Your rounding was a little bit. We just rounded. We rounded that to 300. Because we wanted to round to the nearest spot. So we just rounded everything to the nearest spot. There. Questions over that? One more. If we take a look at example 5, says a blimp hovers above the ground at a height of 1,150 feet. An observer at point A sees the blimp at an angle of elevation of 24 degrees, while the observer at point B sees the blimp at an angle of elevation of 38. What is the distance between the nearest foot that separates the two observers. Again, what part of the triangle do we need to find? The bottom. But this time around, what are we going to do with those distances? Add them. And it's really nice. Our angles of elevation are written for us. Our angles are already inside of our triangle. So you don't have to worry about moving them. So let's do this orange triangle first. And if it's helpful, draw it outside the diagram. I know this is 24. I know that's 1,150. Start at your angle, label your sides. I think we're pretty good with that by now. Look at Sopatella. Which one are we going to use? Which two sides have info? Tangent. Told you. Use it a lot. Use tangent a ton for these application problems. So we're going to say tangent of our angle equals opposite over the adjacent. That's what we're trying to find. Again, x is down low, so what are we going to do? So that we get x is equal to 1150 over the tangent. Make that into decimals. And we get about 2,583. Round the nearest whole number, so 2,583. So now let's find this blue triangle. And if it's helpful, redraw it off to the side. Trying to find the bottom part. Relabel everything. But what did we say the shortcut was? It's going to be the same exact setup, except we have to swap out the angle. So when we have these double triangle problems, the shortcut is, if this was the tangent, this is also going to be tangent. But instead of putting 24, we're going to put 38. And that ratio is going to be exactly the same. Oh, saves you a little bit of time and headache. It's going to be opposite over adjacent. It's going to be tangent. X is down low. We're going to switch around. Again, it's going to be the same thing, but the angle is the only thing that's different. So instead of 24, we just put 38. Plug it in your calculator. And that's about 1,472. Now that we know both distances, what do? To get our final answer. Add them, right? We know the orange part is 2,583. We know the blue part is 1,472. To get the total distance in between, you just add them together. And we add them together, how far apart are those two observers? What is it? About 4,055. There we go. Questions over that? Here's some practice.